Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about instruction set architecture in sequential circuits. So generally, the instruction set architectures are essential factor for making all those instruction in a sequential circuits. Let me see how this instruction set will be acted in this sequential circuits. So these are all the slides I am going to share in this video: introduction, instructions, memory locations, activity, and followed by assessments. Introduction. So generally the CPU has been fetched the instruction based on the two layers. First one is CISC layer has been analyzed, and it has to be fetched the data like softX and OFX. So these are the registers. The register has been fetched by using this ISA layer, and then it is moved to the hardware. So here the hardware is CPU. The once information has been received from the ISA layer, then it is automatically moved towards the instruction set architecture. So once the CPU has analyzed and verified the instructions received from the ISA layer, then only it has to be moved to towards the instruction set architectures. So the memory location has been analyzed, or it has to be understood by the students, or those who are not aware about the instruction execution process. They may be confused about how to execute the instructions. So next we are going to fetch and analyze these type of execution. Then only we can able to send the informations. So the bridge between the words is operating systems and their compilers. So because operating system is the standard one which will be getting the information based on the fetching the input signals, so that it will be forward to the compilers. So when compiler running the informations, it is need to be verified by using this memory elements, because after getting the information received from the compiler, then it will be stored in the memory units. And memory addressing modes. So already we have discussed about the addressing modes. So these are all the addressing modes. Then only it will be used to fetch the information as instructions. And next one is reference instructions. Once the information has generated, we need to check the instructions reference, because it is the factor to get the informations based on the input signals. For example, if we are taking LDA load accumulators, once finalizing the instruction, then it is moved towards the load accumulator. Once the information is right, then it is moved to the store. Then it is called as a store accumulator. And once all the instruction has been stored in the accumulator, then we need to add our additional elements by using the addition operation command. So these are the reference instruction after finalizing the all the instruction to be fetched from the memory elements. And instruction format. So if you are adding any instruction towards the next one, we need to follow the instruction format. First one is opcode plus operand. So opcode is the instructions. It's maybe move or add, like this opcode will be generated. Next one is operand is source and destination address has been analyzed, because so operand may be variables or numbers like that, whatever it may be. So the common instruction based on opcode plus operand only, so that it will be able to generate or communicate with the other instructions. Memory locations. Once finalizing the instruction, then automatically it will be moved towards the memory elements. So there are two type of memories are assigned here, primary memory and secondary memory. So here the cache also playing a vital role, because the cache memory is the one which is used to fetch the information from main memory to the processor. So we need to access the memory based on the both primary and secondary memories. Mind mapping. So once if you are using this mind mapping, we can able to know the particular concept of the fundamentals of instruction set architecture, so that it will be very useful to learn about the particular concepts. Activity. Here I am giving think pairs are. Let us consider RISC versus CISC trade-off. So think is why smartphones use ARM processor, but laptops still rely on Intel CISC processor. The pair is discuss the performance, power, and instruction decoding and speed also. And next, share the summarize in one line. RISC focuses on dash, which kind of information they are providing, and while CISC focus on dash, what kind of information they are providing. So like this, we need to get the informations by using this thing pair share. Assessment. Intel Core i7 processor follow which type of instruction set design? Option A RISC, B CISC, C VLIW, and D is EPIC. So the answer is CISC, CISC, because the Intel processor and laptop we are using what kind of processor means CISC processor, because it's a complex instruction set computers, and they are using a CISC processor for all those processor unit. And next one is the future trend in ISA design across the MNCs focuses on increasing the instruction complexity or reducing the modularity or open source customizable instruction sets or fixed licensing only architecture. So the answer is open source, because we can access at anywhere, anytime, so that we are not aware about the amount of the particular sources of the app. So it will be very useful for the users also. So these are the reference I have taken. Thank you.